In this question, we're going to use Pythagoras to find the height VO. The question tells us some really important information. It tells us that the base is a regular hexagon, so we know that all these sides are equal. It also tells us that O is the centre point of the hexagon, so this point here is midpoint of the hexagon, and finally all of the slope lengths are equal, so we know that these are all equal to the same amount. They're all equal to 7. In order to find out what we need to start drawing on some information. So first of all, we're going to draw on the line OV, because that's the height we're looking for. So next I start to look for some shapes that I can work with, and if I look here, I can actually see a triangle, a right angle triangle here. Now I've drawn that in and I've put on the information that I know, so I know the slope length is 7. What I don't know is the base and the height, so I need to work out how I'm going to find the base in order to find the height. So now I'm looking for things that I know. Well, I know that there is 3. I also know the distance from there to the origin and there to the origin are equal. So that makes an isosceles triangle. So in order to find these lengths here, I'm going to need an angle either here, here or here. Now if I go back to the question, it says that this is a regular hexagon. So actually I can work out one of the interior angles. If I work out one of the interior angles, then I can half it to get this angle here. The interior angle of a regular polygon is made up by n minus 2 times by 180 divided by n, where n is the number of sides. So what we have to do is substitute the value of n for the number of sides. Well, a hexagon has 6 sides, so we have 6 minus 2 times by 180 all divided by 6, and that gives us 120 degrees. So we know that that angle there and the other angles, interior angles, are 120. Therefore we can split that into 2. That makes that 60, and that makes that 60. Therefore that one also must be 60. So it's actually an equilateral triangle. Because we know it's an equilateral triangle, we can then see that if that there is 3, that this must also be 3 and this must also be 3. Let's mark those on. So now we have 2 sides of our triangle, and we can use Pythagoras now to find the height. So I've redrawn the triangle over here. So you can see actually we're finding one of the short sides. So we've got Pythagoras' theorem here. We've got A, we haven't got B, but we have got C. So we'll substitute the values into that. So we've got A squared, let's call that 3 squared. B squared we haven't got, equals C squared, well that is 7 squared. Now what we need to do is rearrange and solve. So therefore B squared is equal to 7 squared minus 3 squared. Get rid of the square by square rooting, so B is equal to the square root of 7 squared minus 3 squared. So therefore B is equal to 6.32 centimetres to 2 dp.